A question many folks are asking is, where was Venezuela's air defense system during the operation led by the United States? We all know that Venezuela owns, or at one point owned, some pretty powerful air defense systems, like the S-300 complex. On top of that, they've got other short-range systems, not as strong but still made by Russia or the former Soviet Union. For a long time, we've noticed that Russia's always been really good at building air defense systems like these. So, why wasn't a single American helicopter shot down by these systems? That's the issue we're going to dive deep into in today's article. I'll explain why no aircraft got taken down, even though helicopters are often seen as easy targets for air defenses since they fly at low altitudes, giving them very little reaction time when hit by a missile. Drop a comment with 1 if you support the United States, or 2 if you're rooting for Venezuela. First off, let's talk about the S-300 system. This is an air defense setup mounted on trucks, carrying missiles in the back, which makes it highly mobile, a huge advantage. The system needs a radar guidance station to pinpoint the enemy's location so the missile can lock on as soon as it's launched. However, the missile itself also has its own radar, so it's not entirely dependent on the ground-based radar at the start. The ground radar, being much larger, can cover a wider area and guide the missile in the early stage. Another strength of the S-300 is its ability to launch missiles vertically, allowing it to hit targets in any direction without needing to pre-align the launch vehicle, unlike American systems like the Patriot, which have to turn the vehicle toward the target. Newer versions, like Russia's S-400, have also overcome this limitation. When launched, the missile shoots straight up, ignites its engine, and automatically heads toward the target with radar guidance. The radar system plays a critical role, and to disable the S-300, one simple way is to destroy the radar. Without it, the missile can't identify a target. This is a pretty formidable air defense system, posing a serious threat. However, in this case, the United States clearly assessed the danger level of the S-300 and found ways to destroy or disable it, though we got to admit the S-300 is somewhat outdated compared to the S-400 that Russia's currently using. A standout feature of the S-300 is its range, stretching up to hundreds of miles, letting it take out targets from a long distance before they even get close. Clearly, the United States was fully aware of this threat and took multiple steps to ensure the S-300 couldn't operate without leaving any trace of their interference. There's an interesting piece of info about the S-300 shield in Venezuela, claiming it's a big lie. According to this, the system never really existed in a complete form there. Venezuela did buy the S-300, but they paired it with radar systems supplied by China, which aren't compatible with the S-300. This meant that even if the radar detected an airborne target, the info couldn't be relayed to the S-300 system due to tech differences. Only when the S-300's own radar picked up a target could the system respond. That's a major flaw. When building a military force, integrating systems is key. Having a radar that can't communicate with the air defense system is almost useless. This shows how important coordination between systems is, rather than just focusing on individual performance. If the systems can't talk to each other, they won't be effective. Besides big systems like the S-300, we also see shorter-range weapons popping up, like MANPAD's shoulder-fired air defense missiles. These are used at close range, with a reach of about 3 miles. In some videos, you can see footage of a MANPAD's launch, often used against targets like drones. These missiles use infrared guidance, and their biggest advantage is mobility. A soldier can carry it into a room, fire quickly, and hide right away, making it hard for the enemy to pinpoint their location. In the videos, it looks like some MANPADs were fired at American helicopters, but they didn't cause any damage. Instead, the defense systems on the helicopters, like laser tech to disable missile warheads, seem to work. Still, some helicopters did take damage, possibly from infantry fire or similar weapons, according to confirmed reports. Going back to the context of the operation, a few weeks ago, many experts already pointed out that American flights near Venezuela's coast were a sign of a bigger plan. Clearly, this operation was carefully prepared well in advance. When the United States deployed B-52 bombers aircraft with a huge radar signature, along with escort fighters, and turned on their transponder signals, Their goal was nothing less than to force Venezuela to activate their entire air defense radar network. Plus, the flight paths of the American planes covered almost the entire Venezuelan coastline, letting them map out the exact locations of air defense systems. Even though the S-300 can move on trucks, they're often placed near airfields for easy missile and equipment resupply. Also, Venezuela doesn't just have radar along the coast, but deep inland too. When they detected a threat, they might have turned on all their radars to search for more potential targets. That's exactly when the United States gathered intel on how Venezuela's air defense system operates, including detection times, operational range, and reactions to different types of aircraft. The United States ran several tests, from flying at lower altitudes using smaller aircraft like the F-18 instead of the B-52, to turning off transponder signals to check the enemy radar's detection ability. All this info was carefully recorded to prepare for the day of action. On top of that, the United States used electronic reconnaissance planes like the RC-135, which specialize in collecting data on enemy radar and electronic systems through antennas and sensors. These planes detect frequencies, amplitudes, and types of electromagnetic waves to understand how each system works. The data collected is then passed to electronic warfare aircraft like the EA-18G Growler. This plane emits high-powered jamming signals to paralyze enemy radar, making them ineffective. Thanks to this, the United States didn't need to physically destroy the S-300 or its radar to disable them. Furthermore, the American aircraft carrier USS Gerald Ford had just been part of operations in Yemen for several weeks, even months, before this. The pilots and forces on board had real combat experience, not just folks pulled in at the last minute. Besides the Growler, other planes like the Eurofighter also have some electronic warfare capabilities. But they can't compare to the Growler, a plane built specifically for this mission. Alongside that, intelligence from satellites, spies, and internal sources played a big role in locating Venezuela's air defense systems, providing precise coordinates for airstrikes. This operation wasn't a one-off or random attack. It was the result of tight coordination between multiple American intelligence agencies and military branches, including the Navy, Air Force, National Guard, and Army, with Army helicopters joining the operation. The goal wasn't just to disable air defenses, but also to locate Venezuela's leadership. In a widely shared video, you can see American helicopters flying into the target area while explosions go off around as air defense systems are destroyed. The attack was synchronized, not striking beforehand but hitting right as the helicopters moved in, to avoid letting the enemy predict their route. At the same time, electronic warfare support came from Growler aircraft. If electronic jamming wasn't enough, targets were physically destroyed with bombs. Drones also played a key role, providing real-time visuals and thermal imaging to monitor the situation, while updating maps of destroyed air defense systems. If any target wasn't neutralized, fighter jets were dispatched to handle it. Plus, aerial refueling planes like the KC-135 were essential, supporting fighters from 20 different air bases, some located far away on the American mainland. Refueling kept the squadrons in the air longer, ensuring they could wait for orders and coordinate smoothly before striking. As for fighter jets, recent info shows the F-22 Raptor was deployed for air superiority, ready to counter Venezuelan fighters like the Su-30 or F-16 if they took off. At first, I thought the F-35 could handle this role too. But design-wise, the F-22 really stands out in air-to-air combat with its speed, maneuverability, and optimized radar. Meanwhile, the F-35 and F-18 were used for suppressing enemy air defenses, SEAD, thanks to their ability to gather and share data from multiple sensors. The F-35 isn't just a fighter, it's a data collection system, automatically sending threat info to allies via encrypted channels, boosting coordination efficiency. In summary, Venezuela's S-300 system was either fully disabled or destroyed. However, poor maintenance, lack of training for operators, and incompatibility between systems from different countries left Venezuela's air defenses unable to respond effectively. This definitely won't make Russia happy, seeing their system bypassed so easily. The United States might use this event to promote their Patriot system, emphasizing that their systems wouldn't be neutralized as easily as the S-300 or S-400. Still, we gotta note that Venezuela's military isn't on the same level as countries like China or Russia. A similar operation against stronger opponents wouldn't go this smoothly. Venezuela's hilly terrain also helped American helicopters stay hidden, something that wouldn't work in every battlefield. I hope this article gives you deeper insight into the recent military operation. My thoughts go out to the ordinary folks in Venezuela. See you in the next posts. Comment 1 if you support the United States, or 2 if you're with Venezuela.